Hello students, welcome to Inside Physics. Today we are going to see some problems at a NEET level. So here our topic is electric charges and fields. The first problem. If two bodies are rubbed and one of them acquires charge Q1 and another acquires charge Q2, then the ratio of Q1 is to Q2 is. See, whenever two bodies are rubbed with each other due to friction, the heat is generated. The electrons in one body will absorb the heat and the electrons will acquire sufficient energy to move to another body. So in the two objects, one loses electron and the same electrons are gained by other body. So here two bodies are, one is negatively charged and one is positively charged, and the charge ratio is negative and positive. So we can take the Q1 is to Q2 as equal to minus 1 is to 1. So both charge having same charge, because the number of electrons transferred are same from one body to another, and the polarity, this is negative, this is positive. So the answer here is C. So here we see the second problem. If a body gives out 10 to the power of 9 electrons per second, how much time is required to get a total charge of 1 coulomb from it? So first of all we need to know how many electrons will be there in 1 coulomb of charge. Then we can easily calculate the time to get 1 coulomb of charge. Already there is an information given, 10 to the power of 9 electrons are given out in 1 second. So how to get the number of electrons in 1 coulomb of charge? We know that the electron charge is 1.602 into 10 to the power of minus 19 coulombs. So in 1 coulomb, how many electrons are there? Just we can take this as 10 to the power of minus 19, gives out 6.25 into 10 to the power of 18 electrons. So in 1 coulomb of charge, 6.25 into 10 to the power of 18 electrons are there. So to get this many electrons, what is the time required? We already know 10 to the power of 9 electrons take 1 second. So how many electrons does 6.25 into 10 to the power of 18 electrons will take? This is a simple mathematical relation, and if you divide the total time to get this many electrons will be, the time will be here 6.25 into 10 to the power of 18 by 10 to the power of 9. So this is around 6.25 into 10 to the power of 9 seconds, which will be equal to almost, if you take this into years, this is nearly equal to 198 years. So the answer will be here D. It is around 198 years. Here we see the third problem. Suppose the charge of proton and an electron differ slightly, which is not possible, but here we are assuming that they differ slightly in their charge. What is the difference? One of them is minus E and the other is E plus delta E. If the net of electrostatic force and gravitational force between the hydrogen atoms placed at a distance d apart is 0, then delta E is of the order. That means, see here, we are assuming that the electron and proton differ slightly in their charge, which is not possible, and here the charge of electron is given by minus E and the proton is given by E plus delta E. So if these are the charges present on a hydrogen atom, what is the net charge on the atom? This is obviously So E gets cancelled. What is the remaining charge? That is delta E. Okay, so here if the net of electrostatic force and gravitational force between the hydrogen atoms placed at a distance d, that means there are two hydrogen atoms placed at a distance d apart. What is the electrostatic force between them according to Coulomb's relation? We have that k into q square by d square. This is the electrostatic force between the two hydrogen atoms, where k is nothing but proportionality constant. We know that k is equal to 1 by 4 pi epsilon naught, and that is equal to 9 into 10 to the power of 9. And what is gravitational force between two hydrogen atoms? The gravitational force is given by Newton's gravitational law. Here G into m by m square by d square. So where G is the Newton's gravitational constant and d is distance between two atoms. M is nothing but mass of hydrogen atom. Here we have taken the hydrogen atom and the mass of hydrogen atom is already given. So if this is electrostatic force, the gravitational force, what it is given? If the net of electrostatic force and gravitational force, what is the net? Means difference. That is Fe minus Fg is equal to 0 is given. Okay, Fe minus Fg is given. That implies we can write Fe is equal to Fg. So here if you compare these and then we will get k q square by d square is equal to g m h square, where h is mass of hydrogen atom, by d square. So what we require here? Then delta E, that means the charge. Here if you cancel d square and d square, what we will get? That implies, so q square is equal to gmh square by k. gmh square by k. So k, here what is q? Delta E, the charge present on the hydrogen atom. So if you substitute these values here, that means delta E whole square is equal to G is nothing but 6.67 into 10 to the power of minus 11 into mass of hydrogen atom is given 1.67 into 10 to the power of minus 27 by, what is k here? 9 into 10 to the power of 9. So if you calculate this value and the charge delta E will come out to be, delta E is equal to 1.437 into 10 to the power of minus 37. So this value will come out to be this one, and the order, what is his, this is not the value that is asked, it is of the order. Order means this one. The order of the charge is nothing but 10 to the power of minus 30. Here we see the fourth problem. Three charges q1, q2, q3 each of 1 coulomb are at the vertices of an equilateral triangle of side L. Then the force on a charge q, which is equal to 2 microcoulombs, placed at the centroid of the triangle is. So here three charges are placed at the equilateral triangle vertices. So there are three vertices, we assume A, B, C, and the three charges are placed at three vertices, means Q1, Q2, Q3. Q1, Q2, Q3. So at the centroid there is a charge placed which is taken as small q. Small q is given by 2 microcoulombs. So here this small charge will experience a repulsion because of the other three charges. So if this charge is having a force, this is, see, if you consider this as O and this is OA, the distance is OA here, and this distance is OB, and this distance is OC. Okay, so the force experienced by this charge will be, this is towards F1. We can say the force between these two is F1, and the force between this charge Q2 and the small charge Q is like this. This is F2, and the charge between the Q3 here at C and this charge will be in this direction. This is considered as F3. Now what is he asking is, the charge placed, this one small q placed at centroid will of the triangle, what is the force on this charge? So this is, if you consider this as centroid as O and the small q charge is placed at that centroid, what is the net force acting on the charge here? So if you consider force F1, what will be it according to Coulomb's law? This will be 1 by 4 pi epsilon naught q1 q by this distance AO square. So if you consider F2, that will be 1 by 4 pi epsilon naught. See, F2 means these two. So the charge will be q2 small q by this distance BO square. Okay, you consider F3 1 by 4 pi epsilon naught q3 q by this distance CO square according to Coulomb's law. Coulomb's law of attraction between any two charges. If you observe this one, so this all the forces are equal because these are the, see, the three charges q1 q2 q3 each of 1 coulomb, because all the charges are equal to 1 coulomb only. So q1 is equal to q2 is equal to q3 is equal to 1 coulomb. So the forces between them is equal, all are equal. That means we can say F1 is equal to F2 is equal to F3. Say this is equal to F. So if you take the resultant of these two forces F1 and F2, what is the resultant of the two forces? How to get the resultant? If this is the force F1 and this is the force F2, let us assume the resultant will be in this direction. And what is the angle between these two forces F1 and F2? This is 120 degrees according to properties of triangles, and this is also 120, and the other thing, the forces between this and this, see all the angles F1 and F3, F1 and F2, and F3 and F2, this one also is 120 degrees. So all the angles between the forces, because the charge is put at centroid, those are all 120 degrees. So how to get the resultant of F1 and F2? By using the formula of parallelogram law, we can get the resultant. So the resultant F12 is equal to root of the resultant of F1 and F2 will be in this direction, and F1 square plus F2 square plus 2F1 F2 cos theta, right? So here F1 F2 all are same, so we can take F square plus F square plus 2F into F. This cos 120. So what is cos 120? Minus 1 by 2. Theta is nothing but 120, the angle between two forces. So here what we will get, see 2 gets cancelled and this will come out to be F square, that is equal to F1 to the resultant of the forces F1 and 2 is equal to F. So which is equal to, we already know F1 is equal to F2 is equal to F3 is equal to F. We already know. So this force, resultant force of these two is exactly balanced by F3 because both are same. So in the same sense, this resultant force of these two will be balanced by F2, and the resultant of these F3 and F2 is balanced by F1. So in the same sense, the net force on the charge Q, because all the forces are balanced, is 0. Now we will see the fifth problem. The electric field in a certain region is acting radially outward and is given by capital E is equal to A into small a. A charge contained in a sphere of radius A centered at the origin of the field will be. Okay, now a field is given by E is equal to A into small a. What is taking the sphere which is having a charge at its center and a radius small a, that is the data. So he is asking what is the charge, what is its value, and the options here are A, B, C, D are these options. How to get the value of this charge? We all know whenever there is a charge inside the sphere, the electric field will be radially outward, right? The electric field lines will be coming in this way, and the field, according to the field which is of a sphere and the charge is at the center, we can get the value as Q by R square. R is nothing but, see here I will write R, and the electric field due to this charge is nothing but 1 by 4 pi epsilon naught Q by A square. Okay. So here this is equal to, the field is equal to given as A into small a. Okay. Now what is the charge here? Q. We want the charge present at the center. So the charge will be, if you take these values to that side, 4 pi epsilon naught A into A cube. So which is option C. So now we will see some more problems in the next session which are very helpful for the students who are appearing for the NEET exam.